Hey everybody, today I will be going over learning target 7, which relates to evaluating limits at infinity. So we are asked to sketch a graph of a function f of x which satisfies the 5 following conditions. So what I'm going to do first is I'm going to mark down the relevant points that it gives us using some dashed lines. And what I mean by that is, for example, we have here the limit as x approaches -1. I'm going to indicate -1. Here it approaches a y value of -3. And then here, value of x is +1. So I'm going to draw a dotted line here at -1. And then since the third condition relates to y approaching -3, there'll be a horizontal line. And then finally, for the 4 and 5, we'll have a vertical line at 1. And these dotted lines are not part of the graph. They're just there to help us draw this. It's a little bit of a tool as we go along. So now we can hop into actually drawing the graph of the function. We have that as x approaches -1. The function will approach -infinity. So it'll be something like this. I'm not going to draw much further than that because I don't know what all the behavior over here and over here is going to look like yet. Next, we have that as x approaches infinity, y will approach infinity as well. So I'm just going to draw a little something like that. Because as I go to the right on the x-axis, the y-axis will also go up. So these two are done. Now we have that as x approaches -infinity, which is going to the left, y approaches -3. So we have this line already drawn out, and I don't have any points marked down in this area, as in like x equals whatever. So I'm just going to draw this line out the rest of the way. Oh, and have a little bit of curvy. Just hugging that line there. Okay, so that one's done. Then we have that as x approaches 1 from the right, positive sign means from the right, our function approaches infinity. So 1 is like right around here. So when you're going to go to infinity, so I could draw something like this. And there are different ways you could draw it. I could draw it like whatever, as long as I'm just obeying that simple rule. But this is the simplest way to do it. And then finally, we have that as x approaches 1 from the left, y approaches -infinity. So as I go this way, y goes that way. So connect these, and there we go. That is our function f of x, which satisfies all the conditions. And then once you've drawn that out, I highly recommend going through and checking everything just to make sure everything matches and is drawn. Make sure there are no discontinuities where there shouldn't be. In these asymptotes here and throughout are discontinuities, but you don't want like a random hole or random gap or anything like that, because then it wouldn't be a function. It wouldn't be continuous there. Okay, so part B now asks us to find horizontal and vertical asymptotes in the graph above using notation for a line. So let's do vertical asymptotes first. Once you have a graph, it's not too hard to identify. So I'll zoom in and look for vertical asymptotes. And this is where these lines kind of help us out as well. So I'm seeing a vertical asymptote here at x equals -1 and one at x equals 1. So I'm going to go ahead and write that in. X equals -1 and x equals 1. And basically when it asks you to use the notation for a line, that just means like x equals something, y equals something. That is a line. So don't be thrown off by that too much. Now we need to find horizontal asymptotes. Similarly, we've kind of drawn these out with our lines. We have one horizontal line right here that is at y equals -3. Okay, part C is asking us to find each of the following. So we have a couple limits to infinity and then finding some vertical asymptotes. Okay, so we have that x is approaching infinity, which is end behavior. So what we can do here is really just think about our biggest terms, or our biggest degree terms in both the numerator and the denominator. So it's not exactly mathematical, but for now, we're just going to forget about these terms. Since as we go close to infinity on the x-axis, these terms aren't really going to be relevant. So I'm going to rewrite this as the limit as x approaches infinity of 3x squared over x to the fourth. This simplifies to 3 over x squared. Now we think about this, we have infinity. So the numerator doesn't really involve infinity, just the denominator. So I'll have 3 over infinity. So 3 over a really, really, really big number is just going to be a really, really, really small number. So you can write this as 0. Similar question here, x approaches negative infinity. So we're just going to think about our highest degree term, which is negative 5x to the 6th power. So we'll once again rewrite this as the limit x approaches negative infinity of negative, oh, I don't really use parentheses, negative 5x 6th power. If I think about plugging in negative infinity, which you can't really do mathematically, but if I just think about it, I'll have some negative to the 6th power, and since this is an even power, I end up with a positive. But then I'll have a negative times a positive, so I will get a negative. So that basically means this is going to be approaching negative infinity. And then finally, we're asked to find the vertical asymptotes of a function right here. So your first thought may just be look at the denominator, which is correct, and see that I have x squared minus 1, and you'll solve this out. And then you'll have x squared equals 1, and then x is equal to positive or negative 1. But this right here is incorrect. And the reason for that is because we can factor out terms in the numerator and denominator and cancel them out. So that's what we're going to do. We're going to factor f of x and see what happens. Well, the numerator is done for us, so we'll have x times x minus 1 over x plus 1 and x minus 1. And then as you can see, we have an x minus 1 and x minus 1. Those divide out. We're just left with x over x plus 1. Now would be a really good time to look at your denominator. Is we know we have a vertical asymptote when the denominator is equal to 0. So we can set this equal to 0. We have x plus 1 is equal to 0. Thus, x equals negative 1. I did not write negative 1. Sorry. X equals negative 1 is a vertical asymptote. Hope all of this makes sense. If you have any more questions, please feel free to stop by the office hours. Thank you.